Okay, I've shared my screen. Let me go over lesson 12 again. This is the last time when we met and we were discussing about MEP, mechanical, electrical, and plumbing. And what I said was that we were going to draw pipes, ducts, cable trays, conduits, and so on. The process of drawing is very simple. Any pipe you draw is associated with a specific level, and it has an elevation offset to the level, either positive or negative. Now, when you are drawing the pipe, it can rise, it can fall, it can bend at an angle at 90 degrees or 45 degrees or 30 degrees, depending upon the design requirements. So if I take, say, this pipe and I start to draw, as soon as I start to draw, I must be sure of the level on which I'm drawing it. Either I'm on level 1 or level 2 or level 3 or level 13. If I choose level 1, it will be assigned to this level 1. Then I can specify the diameter of the pipe. Please bear with me. I'm sick, but I'll have to manage. We have to get this thing done.
Sir, water, please.
If I'm drawing a pipe, I must know the level on which it is. If I'm drawing the pipe, I can click anywhere and start drawing the pipe, and then define a specific length for the pipe, let's say 1,008. When I get to 1,008, I can turn 90 degrees if I want to. I can turn 60 degrees if I want to. I can turn 45 degrees or 30 degrees if I want to, and then continue drawing. If I want to rise up, I'll just have to go and change the elevation to say 0. Previously, it was negative 1,002. As soon as I change it, it will rise automatically, and then I can continue to draw the pipe in the direction that I want. I can turn again. If I want to drop back to negative 1,002, I can do that. Then I can still draw my pipe. That's the main concept of drawing a pipe. If I go to plans, plumbing, level say 1 here, I can do the same thing on plan also. So I'll pick my pipe system, then pick a pipe. As soon as I pick the pipe, I can define the diameter of my pipe. Let's say 150, 6 inches pipe. The elevation of the pipe, let me give you say 0 for now. Then I can start drawing the pipe. That's the pipe. So this pipe that I've drawn, if I select it, right click, and then choose properties here on the right, you see that the pipe has reference level of level 1 and then middle elevation of 0. I'm using middle elevation for now. Later on, I'll explain it when we started it in type. Now, if I want to do another pipe and I right click, create similar, I must check my elevation that I'm drawing the pipe. It's 0. So if I click here, it will continue at the 0. And because they are the same elevation, it will still join it as 1 unit. If I create similar, and still maintain middle elevation of 0 from here to come and join it in the middle, it will automatically add the fitting that is required for it. In this case, if I hold it and drag it at an angle of 45 degrees, it will update the fitting for me from the previous one. If I want to do another one, so it will rise above this one, I only have to change the elevation from here, from say 0 to 1,800. And as soon as I click, Revit will automatically add another pipe there as an upstand. Then I can draw this one. So you see that it will update the symbol, showing me that there's a riser at this point. Then this one will continue. I can take a section here, go to the view, take a section in front here. I want to see only this one. So I'll pull the section back. Then I open the section. The detail level is coarse. Let me change it to medium or to fine. You see, I can see the object here, moving from here, rising to here, and then going that way. If I want to add another pipe from here in section, I can easily draw it from here and draw it in section. Then the pipe will be added with an appropriate fitting. One thing I want you to notice, know where you want to draw, and then create appropriate elevation view or section view or plan view. So you can draw it and then draw it well. If you can do it in 3D, you can do it there. Find a convenient view that you can draw your pipe. So if I come in here and I create similar, I can, in this view, I can go right or left, or I can go bottom. If I go right, I can draw it here neat. But if I want to move forward from here or move front to where I am, it will be very difficult. Then in that case, I might have to draw a different elevation to be able to do that. So I'll have to go to the plumbing again, draw another section from here in front here, then come this way, flip the section, go to the end like this one, open the section view. Now increase the detail level to fine. Where is my view? Take this one, add in view, element, okay. Now my pipe is here, okay. It's we're on level 2. So this is the pipe here. So if I want to move in this direction rather, then I can connect it from here and then move in that direction. I can also connect it from here and move in that direction. I can go to 3D view, then whichever direction that I want to move, I can right click, create similar, and then click it and then draw it. Any question, please?
No, sir.
On a typical site, when we are doing piping drawings, there are 4 types of pipes we work with. One, we have water supply. How you bring in water into the building. You understand? Then 2, we have wastewater supply, how you dispose of water from sinks, showers, wash hand basins, and stuff. Then we have soil waste from WC, how you dispose of the WCs into either a main central sewage system or into a septic tank system or into some of these biofuel systems or whatever. Then with the water supply, you can either get cold water or you can get a hot water supply. If you are doing a hospital project, there will be more different types of pipes and then the kind of even liquids that they might be supplying. And each of them must have their own piping system. As simple as that. Nothing more, nothing less. So one thing that we should take note is that where is the water coming from? Where is the water terminating? Will it terminate in the kitchen? Will it terminate in a bathroom? Will it terminate in a shower room? Will it terminate in a whatever? Now, at that areas, when you are bringing the pipe there, by all means, there's going to be a plumbing fixture that the pipe is going to be connected to. Is it a sink? Is it a WC? Is it a urinal? How many are they? And how are the connections supposed to be made? This is something you should be very comfortable with before you draw. On a typical construction site, people lay the pipes before we fix the WCs. In architectural drawings, we place the WCs before we connect the pipes. You should understand these systems very well so that you can utilize them. Ideally, sitting in this empty space and drawing pipes will not make sense in any way. So for better understanding, I'll need to bring in a building. Then within the building, I'll know where to pass my pipes and where not to pass my pipes. Any question? Any question?
No, sir.
Okay. So I'll delete everything within the project. Who was talking? Was somebody talking?
Yeah, fine.
Good evening.
I was saying you can
Yes, sir. Please, I'm listening. I'm listening. Mike.
Yeah, my friend.
Yes, sir.
Yeah, I said you can continue.
I can continue. Okay.
Yeah.
So what I'll do is that, like I always do, I'll save this file as project. Then I'll call it project file. Then I'll call it plumbing. Save. So it's a blank file. I'll go to the views, browser organization. I'll put it to all. And then go to views, expand all. And then delete everything, all the views. I'm deleting the elevations also. I need them. Then come into the elevation view, then select this one too and then delete. So at least I have 4 elevations to start with. I'll call this one east, north. It's the same process. This we've done over and over again. South. And then west. Okay. So I only have that one. I don't have any plan views. But I'll call this, rename this level ground level. This level I can delete. I've deleted it and left only the ground level because that's what I'm going to work with. I don't know the levels that architecture files is going to bring. I don't have to waste my time creating those levels. I'll bring in the architectural file so that I can work with the levels that came with it. So I'll leave this one for now. I can go to plan views, floor plan, then ground level floor plan. This one, I can rename it as site because it has nothing to do with the floor plan. This one I can call it site for now. So now I can then bring in my architectural model to work with. I don't need this reference place, so I'll delete them. I'll leave only these elevation markers, which are already there. Then I'll go in and bring in my file. So I'll go to minimize the view, minimize legend, minimize schedules and quantities, minimize sheets, minimize families, minimize groups, and then go to Revit links. Right-click, new link. So I'll go in and then pick my architectural model. That I'm working on and choose OP. Then before I choose OP, the positioning. I'll leave it at auto internal origin to origin, internal origin to internal origin. So I'll go to OP. So see that the file is linked. This is the architectural model linked to it. Now, if I go to the elevation south, I'll see my architectural model with its own levels. This is the ground level that I placed here, which is different. So let me rather bring it to the side here rather, and then check here, and then rather uncheck here. So if you observe, the architectural model came with its own levels. The MEP project has only one level. And the levels in the MEP project cannot be the same as the level in the architecture. They're supposed to be different. It's a different file on its own. So I'm going to create its own levels. So I'll go to architecture again, go to levels, and then I can choose pick or I can draw. But this time I'll draw. So I'll draw this level here. I'll rather, can I pick? Okay, I can pick. But I want to draw. I can also draw. Start from here, draw up to here. Start from this one to draw up to there. Start from this one to draw up to here. As I'm drawing, you realize that this one did not fall on this one directly. This also did not fall directly. So I'll go to modify, pick alignment to align this and that. I can lock it. Align this and that. I'll lock it. Align this and then align this one too. this level here, I want the architecture one. Tap this one. Okay. And then this one also.
Mankind, please a quick one.
Yes, madam.
Please, while we are on the modification tools, when it comes to trim, right? Like you draw a wall, like it has a extender, you want to trim it to end. Which of them do you pick, the bigger one or the smaller one?
I'll go over them again. Just be patient.
Okay.
We've not discussed the modification tools very well.
Okay,
I'll
sir.
still go over them, so be patient and get there. Now,
All right.
I'll select
Thank
all
you.
my levels. This level is named 8 mm head. This level is named no head. So I'll select all the instances of no head in the entire project and then change it to 8 mm head. So I have the same thing. So I can put them out a bit. So this is the ground level 2, which is here. So I can rename this one to foundation level. And if you're in an office, which is a multidisciplinary office, that is working on a project, take note, the architects will be working on their files separate, structures people will be working on the files separate, mechanical people, electrical people, service people, landscape people, interior designers, contractor, everybody will be working on a different Revit file. And you'll be linking and then collaborating with each other. That is where the power of Revit lies, please. Revit is not designed for a specific discipline. It's a multidiscipline, a total building solution. So I want you to just note that when you are working, each discipline has its own file. You don't model MEP in the electrical file. You don't model site in a building file. You don't model structures in an architecture file. You take your time and separate them as much as you can. So this one will be ground floor level. The naming convention per each discipline might be different, but for now, that's not my focus. So we'll get there. We are only at the introductory level. Then this will be roof level. So we now have our levels now. We have the foundation level, ground floor level, ground floor level, ground level, and then the roof level. The next thing we need to do is to create the associated views. So I'll go to view menu, plan views, and then create floor plans. So I need, for now, with the service that I'm coming to do, I don't need anything with regard to foundation, but I need ground floor, and then I need roof level, or these two for now. Or I don't even need the roof level for now. When I need it, I'll add. So let me remove it. Go, we're only doing plumbing. I'm not going to do anything at the roof level, so there's no need to add. So I only add the ground floor level, open. So the ground floor level is created. Then if there's a ceiling plumbing, I'm not doing anything on the plumbing in the ceiling. So for now, I don't need a reflected ceiling plan. So the ground floor level alone is enough for me, which is this one. Now, when you bring in this architectural model, it's this architecture. It's a block of file that you are not supposed to edit, but you are only supposed to work with it. You understand? So when you come in here, you can go to the properties palette, and then there's the discipline here and the properties palette. You change the discipline from architectural to plumbing. As soon as you change it to plumbing, you realize that everything will fade out, and only things which are plumbing related will be highlighted, so you know where you are going to work. Currently, because within the kitchen, I did not place any plumbing fixture in the kitchen here. Within the architectural model, they did not show up. But within the bathroom, there's a shower, there's a WC, there's a wash hand basin, there's another shower WC and a wash hand basin here. So I need to be able to connect them with the proper pipe fittings. Any question? Hello.
No, sir, no question.
Okay. Mr. Godwin.
Mankind, good evening.
Good evening. How are you?
I'm fine.
Any question?
No, not yet.
Good. Now, when we come in here, one thing that we should take notice, by all means, we need to bring in water into the house. So we are going to lay a pipe, or we are going to lay a cable that will bring in water into the house. The first question you ask yourself is, what is supposed to be the size of the pipe that you are bringing it in? These are things you cannot do guesswork on it. There are standards that must be adopted. If you don't know, you can ask somebody who understands plumbing for the person to guide you. The person can be a plumbing engineer. The person can be a plumbing artisan. Just humble yourself, go to those people, ask them what you want to do. For now, I'll just go to system. So I'll go to my pipe. The pipe is not sized. You size them later on. So I'll start from the front here. That's where the main pipe is coming from. But as soon as I click drawing, I don't see any pipe because I did not check my elevation of the pipe. Currently, it is 2,700. So which means that it is way above the cut plane. So I'm not seeing it. Let me put it at 0 for now. We can change it later on. So I'll start from here. Then now I can see my pipe. So I'll come all the way to the end here, across the building, all the way to the end here, across the building also. Which means that the pipe that I'm bringing into the house comes straight away from here to here, all the way to the end here. Then I can connect from here to there. I can connect from here to there. I can also connect from here to the kitchen. I don't know if it will make sense to bring the pipe just here so that I can reduce the costs. Am I going to pass through the wall, under the slab, or whatever? Those decisions is more of a design decision. It is not for me to take that decision. So you, the person who is doing the work, will have to decide that, okay, let me pass the pipe here, let me pass the pipe there. But for now, I want it outside the building so it doesn't distract. Now, when I get this pipe here, I can connect another pipe from here. This is the main water supply. Create similar, connect it from here, and then bring it. There's a window here. So I can't bring it to where the window is. I can bring it to the side of this window or to the side of this window. So I can connect it from here all the way to somewhere there. Let me leave it at this point. And when I reach it here, I can always route it to the left and bring it to the sink. I can route it to the right and bring it to the WC. I can pass it all the way here, bring it here, and then add it to the shower. Depending upon where I want to place my shower, whatever. I can come in here also, create similar, and then connect it from here to come and join, say, there. When you add them, Revit add the fittings for you. It adds a fitting here, it adds a fitting here. Now, Next question is, what is supposed to be the size of this pipe? Any idea of the size of the pipe that brings in the main water to the house? Who can help us? The size of the pipe. What's supposed to be the size of this pipe?
The waste pipe or the normal?
Normal main supply to the house.
It's about 6 inches.
No, it can't be 6 inches. 6 inches is 150 mm. That is for waste pipe. We are now talking of the main water supply into the house.
Oh, okay.
Mankind, 1 inch is fine.
1 inch is fine, which is 25 mm.
Yeah.
So I'll select, I'll hover over the pipe. I'll hover over the pipe, tab it, tab it, tab it, and then select everything. When all the pipes are selected, then I can change it to 25 mm. Now let's go to 3D and see it. This is the pipe that I brought in. Let me increase the detail level to fine. So this is our 25 mm pipe coming. And please take note, there's no pipe of this length long. This will come later on when we are detailing them. You look at those details, but for now, let me leave it at this length. This is also a bend here, which is 25 mm bent elbow, because it's the size relative to the pipe. Then there's a T connection from here into this. There's also a T connection from here into that. Now, the next question you should ask yourself is that, what is supposed to be the elevation of this pipe in the ground? Currently, it is 0 degrees relative to the ground floor level, which is not something preferred. Let me add a fake topo to the side so that you appreciate what you are doing. So I'll go to the site level here. I'll go to massing and site, take topo, create topo from sketch. Then I'll just pick a sketch here, finish it up. So it will give us a topo. Now when I select this topo, it's on the ground level, elevation 0. So if I go to 3D now, and then go to shaded, I can see my topo surface here. We've not done site, but I just want you to illustrate something. But ideally, this pipe here, which is bringing the water into the house, should be below the elevation of the what? Of the topo. Okay. So I'll select all the pipes, tab it, tab it, tab it, to make sure that everything is what? Selected. When everything is selected, you know that all the pipes are now been selected. Then you can assign it a particular elevation or a particular level that you want to assign it to. So I'll take this one, for instance, change the level from ground floor level to ground level. I've selected only one, just observe something, to the ground level. And then the elevation by default is 600. I want it to go in the topo, so I'll make it negative 600. This is something we can always change at the right time. So if I change, you see that all of them, because they are connected together, they go into the topo soil. But I can't see it. To make my work easier for me, within this 3D view, I'll go and change the discipline from coordination to plumbing. As soon as I change the discipline to plumbing, automatically, it will make everything transparent. Then I can see my pipes in 3D view. So these pipes now are below the ground at negative 600. How do I confirm? I can go to the east elevation, change this view also to from discipline architectural to plumbing. So I can see my pipes below the ground level here. As you can see, I can go to the north, check, but to do that, it will take me, so I'll select all the 4 at a time, shift 4, because I'm doing plumbing, change the discipline to plumbing. So that if I open any of them, east, I can see them. North, I can see it in elevation. South, I can also see it in elevation. And then west, I can also see it in elevation. So I can see all my pipes. So if I go to any place and I want to bring in the pipe, due to that, the pipe needs to rise from here to that level here before I can supply it. So I'll go to the ground floor level again. The ground floor level, I am not seeing the pipes. That is where a tool like the view range comes in handy. You can use the view range to control what you can see and what you cannot see. Let me explain it well. You see, this model is three-dimensional as we are looking at it. If you go to a 2D view, the 2D view means that you are looking at the building from one plane, from where you are looking at it from, and then you are looking at it to a certain plane from how far you are looking at it from. So if, for instance, I am on the ground floor here, and I'm standing on the plane on the grade 1, and I'm looking at from this plane, and I want to look at all the way out to grade 2, this plane, then anything between grade 1 and grade 2, I can see it. So for instance, if I take a section, and then I draw a section here, this section is defining a plane where the section view is starting from, which is here. So anything on the left of this section will not be seen. Anything on the right will be seen. But if I select the section, it goes all the way to the end here. So anything up to this point will be seen. So if I drag it back up to here, only stuff that falls within this region will be seen. So if I bring it here and I open this section, this door here will not be seen because the section starts from here and then ends here. That's the limit of the section. So if I open this section, you realize that the door will not be seen. But if I only see this particular window, but if I come in here and then extend it here, what it means is that this door falls within the scope of the section. I can see it. So if I open it and turn the display to wireframe, I can see the door as it is there. But if I go back to the plan, and then take the section and then bring it to the front like this one, and then I open it again, I will not see the door. The same way, if I'm working in a plan view, because the pipe is here, and I am on this ground floor, if I'm looking down, then I must look down beyond the elevation of the pipe before I can see the pipe. But if I'm looking down and I cannot look beyond beyond where the pipe is.
Hey, mankind, easy. Please take a short break.
I'm synchro of my
Get some water and take a pause a little, please.
We will manage. So
Hey.
if I want to see this pipe, then it means that I must look beyond this pipe. And the tool to use to do that, we call it view range. View range. So I'll go to ground floor now. Discipline is plumbing. I'll look for extent, view range, and then click on edit. It will tell me that the associated level for the view range is ground floor level. And then the cut plane is 1002. The bottom is also what? Ground floor level. And then the bottom elevation is also what? 0. View depth how far I can see is also ground floor level, and the depth is also 0. So anything below ground floor level, I cannot see. Are you okay?
Yes, sir.
So if I want to see the pipes, the bottom should be where? This bottom elevation should be where?
Unlimited.
For now, you can make it unlimited. And then the view depth also, let the unlimited, the bottom and then the view depth be the same for now. So both unlimited. If I apply now, I can see my pipes. You understand? So you go to OK. So now I can easily draw my pipes here. But to draw my pipe, I must choose an appropriate elevation that will make the drawing of the pipe easy for me in this view. I'm going to draw the pipe in this wall and bring it up in this wall before I bend it to the right and I bend it to the left here. So I can go to this section view and then see this pipe as it is here. I can bring it into this wall. For now, let me bring it outside the wall. Then I can right click, create similar, and then draw the pipe all the way from here and then bring it to the top somewhere here. So if you see that I've drawn my pipe and given it a height above. Now, when we are laying pipes, there are standards of how high the pipe should be. It's not for me to teach you that. You must find out and know when and where to draw them. Mine is to show you the possibilities of it. So you can let the pipe be on the surface of the floor. You can let it below the surface of the floor. You can let it go all the way to the ceiling and then drop it. The decision is yours based upon your understanding of plumbing. If you want to do proper plumbing work, go and refer to your plumbing notes. Now, when I bring this pipe, I can start to bring it inside the wall, inside the wall, or inside the room, outside the room, inside the wall. Wherever I want to place it, I can place it. Some people place it outside. They don't care. Some people place it inside the wall. They chisel it and place it inside the wall. Let me increase the detail level to medium or fine, so you can see the size of the pipe in relation to the wall. So that if you want to give proper drawing for somebody to do, then let the person know that this pipe here is offset from this wall by, let's say, this kind of what distance from here to there, which you can specify. So currently, if I select it, this is my pipe from the surface of the wall. Let me increase the scale to about 1:25. From the surface of the wall, it's about 20 mm. If I select it and I want to make it 10 mm, I can make it 10 mm. If I want to make it 50 mm, I can make it 50 mm. The decision is on you, the designer. But for now, let me make it 25 mm. So when you plaster it, it will cover the pipe and it is inside the wall. So if I go to 3D, I should see my pipe coming in, rising, all the way coming up. Any question?
No question.
No question. Now, when I bring the pipe up, I must then distribute it. I must connect some to the shower, connect some to the wash hand basin, and then connect it to the what? WC. So if I want to send some to the shower, I can come to a 3D, right click, create similar, select from the top here, move in this. You see the elevation is not specified. When I try to draw, it default to the elevation here. So I want the elevation to be relative to the ground floor. I want it to be 450 relative to the ground floor. So I'll come in here, click here, and then draw to the left. So that will be my pipe. So this pipe here will go in this direction of the shower. If I select this fitting, I can add another fitting to the left. So if I select this one to right click here, add a pipe, draw pipe, then I can draw another pipe in this direction also. Now, if you don't get it in 3D, I can go to the ground floor again, take a section here. That is one good thing about Revit. We have working views and then we have views for presentation. So with your working views, you can create as many sections, as many views as you want. I'll open this section, open it up a bit, bring it up a bit, send the detail level to fine, so I can see my pipes. So this pipe goes through behind the WC and it comes all the way into this wall here. So which means that I can direct it to come into where the sink is. So I can go to the ground floor level again, select this pipe, right click, create similar. And if I go to create similar, the same elevation of 450, I'll connect this to this pipe and then bring it to where the sink is, up to this point. Now, this pipe is still inside the wall. Let me change the detail level to fine so I can appreciate it. It's too much away inside the wall, so I'll bring it to the left. For now, I'll use eyeballing. Later on, you can add dimensions to them to get the right thing done. So this pipe is coming here. I've bent it to come here, which I can easily connect to this one. Then I'll take this one to bring it to this corner here, right click, create similar, connect it from here, bring it to where the shower is. So if you look at it in 3-dimensional view now, there is this pipe all the way coming from the base, rising to this level, turning left to where the sink is, turning right all the way to where the shower is. Now, when I get to where the shower is, I might need to raise the pipe up again. So I'll go in, right click, create similar, and instead of it having an elevation of 450, I can have an elevation of 2,100. Okay, so as soon as I click, it will go up 2,100, then I can draw my pipe this way. So this pipe is now here, coming all the way here, bending here, rising here, and then turning at this angle. Let's look at it from different angle so you can see it. So this is a pipe. This height can be too high. It can be too low. That decision will come from the way you want to fix your shower. Or you can just select it, the properties, change it to a value you want. Let's say 1,800, if that's what will make sense. And if it is 1,800, then you are somebody who's taller than 1,800, then that person's head will hit the shower. So it's all boiled down to design. Now, how do I connect it to the wash and basin too? So I'll come in here to where the wash and basin is. As you can see, this pipe here, I need to raise it, create similar. And I want it to come up, not from 450, let's say 900. Okay, and then select this one, come up 900, go this way, and then my pipe is also there. This design that I am doing might be wrong in your opinion. It might be right in your opinion, but I am only teaching so that you understand the concept, how it works. The whole idea is, how do you route your pipe so that it can get to where it's supposed to what? Get to. Any question? Any question, please?
No, sir.
So
No
this
question.
pipe here has not been connected to, you see there's a tab here. I must find ways and means of connecting this one to the tab here. It's very close to the tab. I can select it in 3D, go to the top, like this one. Use arrow key, bring it all the way down. So it will fall just under the tab. I can use alignment to do that, but the arrow key comes in handy, and I'll bring it back to the middle like this one. So if I have this one, I know that my pipe is just beneath this one. I can bring it below, above it, so that I can later on use a flexible cable to connect it if I want to. This length, I can reduce it for now, so that at least I have my piping system designed. I can supply water to the sink. As simple as that. Am I clear?
Yes, sir.
Now, the next thing we need to do is that we need to supply pipe to the WC also. I beg, I'm only laying the pipes. The WCs and then the sinks and then the showers we are seeing here, they came from the architectural model. So as an MEP engineer or a piping engineer that I'm working, I'm only using it as a guide to work. If I want to get proper WCs, proper sinks that I can specify as a services engineer, which we need to do, then I need to introduce those ones. But I'll get there at the right time. So now we've supplied the pipe to the shower. We've also supplied the pipe to the sink. We need to supply to the what? To the WC. So I'll go to the ground floor, select this pipe.
Hey, Charlie.
This is my code. I don't know whether it is covered or what.
Mankind, drink water. Drink water.
Okay, here. Now I'll take it from here.
Hey, but go and get the water and come, Anna.
Let me teach. I'll finish very soon. Just 1 hour.
Hey.
Please, we
I'll
beg.
come in here. Start
So
another
you're
pipe.
scaring us, honestly.
I'm killing
Oh.
you.
You drink water, drink water.
You're scaring us.
Give me a minute. I'm coming.
Okay, okay.
Indeed. Hello. I've gotten water.
Someone, yes, you sound better.
Now, I need to connect this pipe to this WC. So I can come in here. The elevation is 450. Right click, create similar. So I'll start from here, 450 up to the middle here, and click. I need for it to rise to kind of meet the WC at the side. So I increase the elevation to 900. Okay, then connect it to this WC as that. So if you look at it in 3D, you see the pipe connected to the WC. Now I might have to go to the elevation to check if I'm doing the right thing. It's way above the height of the wood of the WC. So I need to select it and then decrease it from maybe 900 to say 600 sharp. Then I can connect it to the WC. So I've connected water to the WC from the pipe here to this. I've connected it to the sink. I've connected it here to the shower. Then I've brought it from the road, the main. The question still is, are all the sizes of these pipes supposed to be 25 mm? if they are not supposed to be 25 mm, they are supposed to be changing sizes, then you can select the pipes that needs to have change in sizes and then update them. Can somebody help us on that one? Hello.
Hi.
Yes, sir.
So most of the sanitary appliances, like the wash hand basin and the WC, you have to use a flexible connector.
Mhm.
You use a flexible.
But with the pipes at the 25 mm, it's okay for now.
So it can further reduce to 20 mm.
20 mm. So
Yeah.
from where do I reduce it? Is it from this connection or from here or from where?
So each
And
of the
God, don't worry yourself. This is something I want all of us to understand. Revit cannot do that for you. That is where your knowledge and your experience as a building industry professional come in, so you can do the right thing. So if you don't know plumbing and you don't understand plumbing, don't force yourself to do a plumbing model. But if you think you can go and research and then size piping properly or whatever, then it is at your own discretion. There are flexible pipes. I'll come back to them. But I want to exhaust on pipes before we look at them. If you go to system, there are flexible pipes here. Flex pipes. Okay. So you can easily connect a flex pipe from here and then draw it any way you want. You understand? But you look at it later on. If you look at it later on. For now, let's focus on the pipes. So now we have water supply. We've done one side. We can easily mirror to this side if it is the same. If it's not the same, then we might need to redraw them again. So now let's do liquid waste. Then after the liquid waste, then we do the soil waste. But before I do the liquid waste and then the soil waste, if you have any question, you can ask. Any question?
No, sir.
Mankind,
Yes, sir.
please, for this pipe water supply, what of the vibes used in them? You see, usually for the sink basin, it has
I
its
can't hear you well.
vibe. For the shower too also has its
I
top
can't
vibe.
hear you well, please.
Oh, am I clear now?
Yes, come again, yes.
So I was talking of the vibe used in most of the water supplies for the sink, the WC, and the shower.
Mm-hmm.
So each have its top vibe. How about that one? Are
We've
we
not added the
adding?
details yet.
So that's going to be for the detailing.
Yeah, when later on you come back to the detail of it, how to add valves, how to add, we call them pipe accessories, the plumbing accessories. We've not added them yet. We are only laying out the pipes as of now, just the basics of it.
Oh, okay.
Yes,
Thank you.
yes, sir. Any other question? Okay, now let's do the waste pipes. We will get a waste pipe from this sink. Then you get another waste pipe from this shower. And we need to connect the two and then send them outside to a location as a different waste pipe. So you go to the ground floor. This is the sink point. This is the shower point, the waste location for the shower. Maybe I want to bring it out here. So I have to connect the sink waste from here, connect it to the shower, and then take it outside. So this is what I'm going to do. I'll draw a pipe, again, system, and then pick a pipe. And then my waste pipe, I'll choose a different size, 100 mm, maybe 4 inches for the waste pipe. I might be wrong, I might be correct. I'll draw it from outside here, all the way through where this one is.
Hello.
Yes,
Okay.
madam. Yes, madam.
Yeah, quick question.
Okay.
I wasn't here at the beginning, but I don't know if maybe you mentioned it.
Okay.
The pipes,
Mhm.
are they in the Revit families or you have to download them yourself?
They are in the Revit families.
Oh, okay.
If you are looking at pipe design, pipe design is defined by the kind of fittings you are working with. So if you take this particular pipe we are working with, for instance, this pipe here, it's called a PVC pipe.
Okay.
If you go to edit, there's what you call routing preferences here. If you go to edit again, there are specific fittings assigned. Elbow, generic standard. T, generic standard. Cross, generic standard. Transition, generic standard. They're all generic. So in effect, even the fittings assigned to the pipe that we are working with here are not PVC fittings. If you look at them in terms of design, they are not PVC fittings. So the kind of fittings that you define in these routing preferences will define the kind of pipe that it is. And Revit comes with libraries of fittings for pipe segment, elbows, preferred junction type, junction crosses, transitions, union, flange, cap, and so on. So you must know which fittings that you need to create a particular pipe type. But you look at it again. For now, our focus is being able to draw the fittings. So if you want to do a PPR pipe, currently under pipes, we have chilled water pipe, default, PVC, DDW, and then the standard. Okay. So each one of them has a different fittings. So if I go to PVC, DDW, DWV, and I go to edit the routing, you see that it's using proper PVC what fittings for them. Okay. If I go to, let's say, the different family, chilled water type, and I go to edit the preferences, it's using carbon steel, schedule 40, elbow, welded generic. Most of them are generic. So you cannot depend on some of these things to do a proper work. These are just samples that they've shown you. But if you know what you are doing and you know what you are about, there are proper fittings for any pipe that you want to work with. So you must understand the pipe fittings you want to work with and then load them into the project and then work with them. Let me show you something. If I go to insert, for instance, go to manage, go to insert, load family. Then I go up one level, another level, UK, then go to plumbing, and then go to MEP, plumbing. We have fixtures. These are fixtures, appliances, and so on. But I want pipes, so not plumbing, but rather pipes. Go to pipes. Then go to pipe accessories and fittings. If you go to fittings, we have galvanized malleable iron fittings, ductile iron fittings, cast iron fittings, carbon steel fittings, stainless steel fittings, copper fittings, mass steel fittings, PVC fittings, and so on, HDPE fittings, and so on. If I go through this list, for instance, I don't see any PPR fittings in these default settings. So if I want to use a PPR pipe, then I must go and look for what? PPR what? Fittings. So let me, for instance, open the PVC fittings here, for instance. We have solvent welding. We have this fitting, that fitting, that fitting, that fitting, that fitting, that fitting, that fitting. And the question you should ask yourself is that if you come into this library and you don't get the kind of fitting you are looking for, you might say that Revit is not giving you the fitting that you are looking for. You go through the internet and you also don't get the fitting that you are looking for. Then you may look standard. Okay, then let me use the standard one. Meanwhile, in reality, you cannot use the standard one because you are going to cost it, you are going to build it. You must know how you can create your own fitting. And that is where the family editor comes in, which is beyond the scope of this course, by the way. So if you go to the family editor, then you can model your own custom fittings to the standard. Is your question answered?
It is, but why are you saying it's beyond the scope? As in, you will not teach us to model our fittings or what?
This is an introductory level class.
Boy. So,
This is an introductory level class. Please, I'm introducing you guys to what Revit is capable of doing.
Yes, sir.
Thank you, madam. So in a future date, I might introduce mastery modeling or mastery modeling services, mastery modeling structures, mastery modeling architecture. But for now, I'm only introducing you to what is possible with Revit. That's why I call it essential training. And if you don't necessarily have to know how to model it, you only need to get access to it and then use it. If you need those special fittings, you can send me a schedule of those fittings, a brochure, or some, a bulletin of those fittings. Then I can custom model them for you at a fee so that you can use it to work. If you are not ready to learn on your own. Are you okay? If you go to beamobjects.com, there are a lot of libraries there. Some people sat down and modeled them. If you go to Revit City, there are a lot of libraries there. Some people sat down and modeled them. In our part of the world here, somebody also needs to sit down and then model the kind of libraries that we need. For instance, jealousy window, louver blaze, and so on. And that thing, you either learn how to model it, or you find somebody who can model it and then do it for you. You cannot put a fixed glass window into your project and describe it as a river blade window. It doesn't make sense. We have a long way to go. If I should say that Revit is a 32-gear car, we are still in gear 1. We've not moved to the second gear because we are still learning how to create stuff. How to manage and edit them, we've not started.
Gear 1 in Pony.
Yes, sir. You're in gear 1. Just sit up. That's why I'm worried that you guys are not getting time to practice. Because if you don't make time to practice, there's more we need to learn. We've not done view management. We've not done sheet management. We've not done settings. We've not done anything yet. We've not looked at walls in details. We've not looked at floors in details. We've not looked at stairs in details. We've not done anything yet. So if you still see it that you know a lot, it's very unfortunate. When I started Revit training in 2009, some people got to know how to do some few works. Then they started calling themselves BIM manager. You will send a quotation to an office, then they go and send another cheap quotation to that office. And they say, oh, mankind, this party brought this quotation, you are too expensive. Okay, if I'm expensive, so be, move with that guy. So in 2014, I became redundant. I didn't get work to do, so I had to suspend this whole Revit stuff. And people have stuck to what I taught them, the essentials, for the last 11 years or so. Nothing has been added. So take note. You are not too far away from the average Revit you say in Ghana. You just have to up your game. Can I do my waste pipes?
Yes, please.
So I'll go to the ground floor level. Now, you see, when you are doing design, you should take note of some few things. There's a plumbing here also. There's a plumbing arrangement here. Then there's also a plumbing arrangement here. So you must design your waste pipe in such a way that they can easily be what? Connected. You understand? So instead of me starting from here, I'll connect this one to this, bring it outside here. Connect this one to this, and then bring it outside here, so the two can be connected. So I'll start here, go to system, go to pipe. Choose the size, 100 mm. Elevation, let me give you negative 450 below ground. Then I'll start from here and then draw all the way to here. Okay, later we can edit it. We can be wrong or we can be correct. Okay, let me do, let's say 30 degrees up to here. Come straight here, then go outside here. So the waste will come from here, pass through here, and then go outside here. I need to connect it from this one to come down. Now let's go to 3D and appreciate it here. So this is the waste pipe coming. This waste pipe needs to be connected to this sink. So I'll take this one, it's negative 450. Create similar. I want it 0. Wow, connect it to this one. Say this here. And then delete the top. So this one can easily be connected to this one. Pass through here, come in here. Now with this sink also, I need to connect a pipe from this sink to be connected to this one. So I'll select this pipe. So with this code, I beg. So this sink, a pipe need to be connected from this sink to come and join to this one. So I'll create similar. I want it to start from negative 450, no negative 450. The rest is 0. So I'll connect to this one, then bring it up. This one I can delete. So in effect, I have this pipe, which is coming from this sink, moving this way, coming here, turning, and then going that way. To be able to connect it properly to the sink. To be able to connect it properly to the sink, I must go to the right elevation. This is the position of the sink. This is the sink here. This is my pipe. I'll adjust it to the left. One thing will be coming up later on. When the pipes become so many, this one is for the waste. Soil too will come. Then you must know the elevations of each of the individual pipes. Whether the waste pipe should go up or whether the soil pipe should go down, those things will also come as we move along. Okay, good.
Sleeping.
So we have this pipe coming here, going there, going there, going there. Now we must find ways and means of connecting this pipe to this sink and there a flexible cable might come in handy. Any question? The elevation of this pipe, you can change it from negative 450 to, let's say, negative 300. If that is what will solve the problem, then the whole thing will come up. Any question? And if we finish this tutorial today and you don't go and practice it, then you wait till you meet tomorrow evening and assume you know, you're a liar. You must practice.
We'll practice, don't worry.
I hear, madam. I've heard this over and over again. Now, you need to do that for the WC also. So if I go to the ground floor now, I can see my waste pipe coming from here, through here, going there. If I want to turn it at an angle of 45 degrees, I can turn it. But I need to do the WC. The WC also, I'll create similar. This time around, 150 mm. It will come from the outside. Ideally, it should be in the middle of the WC. So, but this one is not a plumbing WC, but I'm only drawing pipe, so I'm just using eyeballing to do whatever I'm doing. So I'll start it from elevation of, let's say, negative 450 again. From the outside. And then bring it all the way to the middle of this WC here. Okay. Then when I'm here, I'll raise it, let's say 600. Then just draw it this way. So there will be an upstand. When I go to 3D, I can see this one here, but I'm not interested in this for now. My WC is shadowing the thing. This WC, I want it also to be transparent. So I'll go to VV, visibility graphics, go to plumbing fixtures, transparency, make that one also transparent so I can see it. Okay, so I can see my WC here. So this one can go, this one too can go. And then this pipe here, I'll look at it from the side. Per the design of the WC, which means that it should come here all the way, okay, to somewhere there. And then adjust the height. If it is P-trap, if it is S-trap, whatever WC fitting that you are going to put in, you know the exact position to place it from the wall. So I've done this one too, as simple as that. If it is a multi-story building, you must know how you can connect them. Any question? Please, Revit is a very interesting software. But you as a building industry professional, you must be on top of your game. If you are on top of your game, Revit can help you in so many areas. Right now, we've not looked at any details. We've not added any fixtures. We've not added any special fittings. We are only trying to get a layout of how the pipes are connected together. And please, what I'm teaching you from basic principles. This is not how we are going to handle a real project. Assuming you are doing a hospital, a big hospital complex, I want to assure you, you are not going to manually be drawing pipe like this one. But because you are doing an introductory class, you should understand how to draw pipes, how to draw ducts, how to draw fittings and stuff. But there are proper methods of doing them. You understand? We don't do them like this one, but this one, I'm only teaching from first principle, just for you to understand the concept and then the principles. Are you okay? Any question?
Yeah, no question. Yeah, we are okay. Wait, I think, why are the pipes inside bigger, or it's just for demonstration purposes?
Oh, this one is 150 mm pipe for the waste. This one is 100 mm pipe.
Okay. All
And
right.
for water supply.
Oh, okay.
Now there's another a plumbing whatever here at the side. So if I go to the ground floor, which means that I need to do this one. And see, this one is still modeling. In terms of documentation, I need to document it so that when you are presenting it on a sheet, it will make sense. That's why I was still coming under presentation, annotation, documentation, and stuff. And do you know one interesting thing? I can do a schedule for all the pipes that I've done here, and then the fittings. So let me do the schedule for now, so you appreciate it. So I'll go to my view menu, schedules, schedule and quantities. Choose pipe. Pipes. Where's pipe? Plumbing fixtures, plumbing equipment. Where can I find pipe? Not plumbing fixtures. Mechanical piping. Okay. Pipe. So these pipes. So I want to do pipe schedule. So with the pipe schedule, I want to know the size of the pipe. I want to know the type of the pipe. I want to know the family of the pipe. I want to know the inside diameter of the pipe. I want to know the length of the pipe. I want to know the middle elevation. Okay, I don't have it here. Is there elevation? I can add cost. I can add the count, critical path, the description for the pipe, the diameter of the pipe. These are default parameters. Play with them. The flow state, fixture units, flow state, friction factor, IFC predefined type, image, if you have, insulation thickness, insulation type, keynote, loop boundary, lower end bottom elevation, lower end top elevation, manufacturer, model, outside diameter, overall size, reference level, system description, system name, system type comments, type mark, and so on. When I get all these things, I can rearrange them. Which one should come first? Which one should come second? I want the reference level to come first. The level on which it's associated with to come first. Then I want the type mark to come second. Schedule, get used to scheduling. Then I want the type to come third. I want the size. I want the family to come before the type. Inside diameter, the length, description, diameter, end bottom elevation, answer, overall size, blah, blah, blah. Good, okay. Then Revit to generate everything for me. I have not assigned a type mark, so it's empty. The type is standard. The sizes, we have 25 mm pipes here, then we have 100 mm pipes here, then we have 150 mm pipes. Inside diameter is given. The length of each pipe is also given. There are no description yet. The diameter is also given. And lower and bottom is given. Lower top elevation is given. Outside diameter is given. Overall size is given. System name. Currently, everything is domestic cold water, domestic cold water, domestic cold water, domestic cold water, because we've not systemized them. But when you do systemization, you know which one is cold water, which one is hot water, which one is wastewater, which one is soil water, everything, but we've not done them yet. System type is also given, and then type comments. This time you can go on further and format them in a manner that makes sense to you. You can create a sheet. Let's say any sheet.
Oh, Rade.
Go to the legends, schedules. Take the schedule I want. Filter by all. Look for my pipe schedule. Drag it and put it on the sheet. Then you see all my pipes by their sizes, by their everything. If I want to do pipe fitting schedules, I'll go to schedules again. New schedule and quantities. I want pipe fittings. So I'll go and look for pipe fittings. If I want to do pipe accessories, I can do that. If I want to do pipe insulations, I can do that. If I want to do pipe placers, I can do that. If I want to do pipe systems, I can do that. But I want to do pipe fittings. Go to OK. So the pipe fittings, I want to know the cost of the pipe fitting, the comment I've given it, the count of the fittings, the description of the fitting, the elevation from level of the fitting, the extent, blah, 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 family of the fitting. If there's an image, I can add it. The insulation type, keynote, the level the fitting is on, the model of the fitting, the size of the fitting, the system abbreviation, system classification, system name, system type, type of fitting, type mark of the fitting. What do you want? And please, all these parameters here, I call them default parameters. Default parameters. Until you realize the limitations of these default parameters, you don't qualify to do the mastery level course I'm talking about. So you guys should be able to use this software, explore it, get issues, raise them, get answers to them, explore all the default parameters within the software. Then to get to a certain point, you come to a realization that tell mankind, I want to create a custom parameter. I want to do that. I want to do that. That is when you qualify to do the mastery level of course. But for now, take your time and explore this. You can rearrange all these things again. So I want the level to come first. I want to see the type mark. Second, I want to see the type as the next item. You can rearrange them. You can remove them as and when they make sense to you, and so on and so forth. Then you go to OK. Then you see all your fittings. So they are all on level 1. The type is standard type. The comment is here. The count is here. Description is here. Elevation, the family. We have the elbow, this one. So there are different types of families. So I want to group by family. So go to edit, grouping, group it by family. Family. Then make it a header. Go to OK. So I'll see the M elbow family fittings. Then I'll see the MT fittings. So currently, with the work that I've done, there are only 2 types of fittings that I'm using in the project. Elbow fittings and then T fittings. There's nothing more. Unless I go into my project again, go to the ground floor level, come into this pipe, break it, take the break tool, break it here. As soon as I break it, I can deselect it. Do you understand? Then change this one to a bigger pipe size. Let's say 100 mm. Then I'll just connect it to this one. As soon as I connect, it automatically add what? A fixture to this one. When I go to the fitting schedule, you see that there's a new fitting added, transition fitting added from 100 mm to 25 mm per the size. And when I'm done, I can go to my sheets, go to my schedules, pipe fitting schedules. Where is it? Pipe fitting schedule, drag it, come and put it on my sheet. If I want to do legends, go to legends, new legend, give it a name, pipe fittings or pipes. Let me do pipes first. Now I can go to pipes. Then I can go to annotate, legend component here, legend component. When I go to legend component, I'll see all my legend components here. The one that are in the project, I can search for pipe, P-I-P-E, pipe. So I see pipe fittings, PVC, schedule, whatever, select it. Then I can come and place it. Now if I select it, detail level, fine. I can see it well. When I select it, and I want to see it in legends here, I can go, I want to see it in floor plan, or I want to see it in elevation. I can see that. I want to see it in section. I can see that. I want to see it in floor plan, left or right. I can look at it. You see, these are the things we are talking about. And if you do this one, I have not drawn anything. I'm only generating, so I can copy it. CO, copy, bring it down, come back here, put this one here to the side here. This one is in elevation right. I'll put this one into floor plan so I can see the two of them. So this on plan, this in elevation right. If I want it elevation left, I can come in here, elevation left. If I want it in a different location, CO, I can put it here and then change it to elevation something else. So I've done elevation right, I've done elevation right, let me do elevation back. So I can see my pipe in all directions. I can drag that one also onto my sheet. So I'll go to the sheet here, take my legend here that I just did, pipes, drag it, come and put it on my sheet. It's too small. I can increase the scale from 1 in 50 to 1 in say 10. Then to come bigger, or even 1:1. Then I can position it. What are you talking about? This is how the workflow is supposed to be. But if you've not modeled it, you will not get it. If you decide to use line work to do it, you are digging your own pit. Any question? Any question? And these schedules.
No question.
No question. And please, these schedules, it's the first time you are going to do it. You will take your time and you are going to format the schedule, arrange it in a manner that makes sense to you, and then save it as part of your work. Then later on, I'm going to show you how you can create your own template and then save the template. So within your template, all these sheets are created. Your custom title block is designed. Legends are already there. Schedules are there. Everything is there. So when you get the project, you only start working. And by the time you finish working, your schedules are updated, your legends are updated, your sheets are updated, everything is updated. A work that will take somebody 1 week will take you a day. And this we are not willing and prepared to pay for because we think it is expensive. And we've allowed the white people to invest money in this one. And all the good works, they are taking it away from us just because we don't want to invest in whatever we are doing. There's no time for anybody. Revit came in as far back as the year 2007. I decided to opt for it in 2009. In 2014, I just have to left it out because nobody was interested. Please, we need to sit up. And this is for plumbing only. We've not done mechanical. We've not done electrical. We've not done firefighting. We've not done surveillance systems. And I don't think it will make sense for me to teach you at the introductory level all building systems. You get confused. You get confused. So you must start from somewhere. Understand plumbing at the basic level, residential scheme, 2-story, 3-story. You must understand electrical, residential scheme, 2-story, 3-story. I expect you to use this software to work on real life projects. Bring the real issues, let us solve them at a very small project level, like 2-story building, 3-story buildings. When you do 10 of those projects and you know that you've arrived, you can do a project and present, then you'll be ready for the mastery level course. I will not encourage any of you to come and do Revit because you are not ready for it. Nobody's ready. At all, nobody's ready. So let's take our time, understand the basics, fundamentals, work with the default parameters, get used to them, get comfortable with them, get control over them. Then you can challenge yourself that now I am ready to do the mastery in Revit. Because as soon as I start introducing some of the mastery concepts, you even get confused. Look at systems here. There's something called system browser. Let me go to view. And then go to user interface. And then open system browser here. We have different systems for buildings, mechanical systems, piping systems, and electrical systems. Under piping, we have domestic cold water. That's what we've done basically. We've not updated it. But beyond the domestic cold water, there are different kinds of systems that you can create. But if you go to the systems tab here, and then go to the settings, piping here, then go to piping settings, which we've not yet looked at, which we are going to look at later on. We have duct settings, we have pipe settings. Within the pipe settings, we have different kinds of annotations, pipe annotation, prefix, suffix, pipe connector separator, and so on. Angles, you can set your angles that you want to work with, default angles you want to work with pipes. Conversions, pipe conversion, elevation and branches, and so on. Segment and sizes. You can define your own pipe segments that you want to work with so that you don't just pick any pipe and then work with. Fluids, you can define the kind of fluids you want to work with, whether it is water, propylene glycol, ethylene glycol, anything. You go to slopes, you define the slopes you want to work with, calculations you want to do. Everything is there. Hydronic networks, pressure drops, flows. Every information is there that you can update as a services engineer. If you do not understand services engineering and you do not understand this equation that is here, you keep yourself in a cage. But if you are a services engineer, then you know what you're about. Colebrook equation, that is it. Harland equation, you can get it. And you can work with anything that you want to be able to work with. If I go to pipe and so on and so forth, if I go back here under mechanical settings, we also have mechanical settings also, and the things that you can do with them. They are all there. If you go to, let's say, electrical settings too, we also have electrical settings, which you can do. The angles, general settings, wiring, gap of wiring crossing, hot wire tick mark, ground wire tick mark, neutral tick mark. Please, we've not done settings, voltage definitions, distribution systems you want to work with, cable tray settings, rise drop, single line symbology, two line symbology, sizes of cable trays, conduit settings, rise drop, single line symbology, two line symbology, sizes of conduit settings, load calculations. You can do different load calculations for all your projects. We have load classification types for appliances, dwelling unit, cooling, electric dryers, elevator, equipment, farm load, everything is catered for. If what you want is not here, you can create a new one, add it to the list. You can define their power general, their abbreviations, demand factor. If you go to demand factors, there are different demand factors defined that you can work with. Everything is there. The only thing you cannot do in Revit is what you don't know as a building industry professional. But if you really think you know what you know as a building industry professional, I am telling you on authority, Revit has room for everything. Unless you don't want to learn. There is room for everything that you want to learn. And you can do all those things. And if you want to do electricals, everything is there. Let me go to, let's say, a 3D view here, for instance, and then go to electricals. If you have electrical equipment, let me go to manage, and then go to, let's say, for instance, panel schedule templates, manage templates. There are different templates. Branch panel template, branch panel with auto shading, feed through line tags. If you want to apply the templates, everything are all there. You can define your own, you can do anything, and you can manage anything that you want to be able to manage. Please, Revit is not limited. If you go to MEP settings, we have mechanical settings, electrical settings, fabrication settings, electrical conductor and cable settings, load classifications, demand factors, building space types, building space type settings, building operating schedules, electrical analytical load type settings, and so on. You need to know what you want to do. Structural settings, connection settings, panel schedule templates, everything is there. If you go to additional settings, there are so many settings here, and we've not started with any settings. What we are currently doing is how to create the items in the first place. And if creating pipes, creating duct, creating walls, creating beams, creating columns, creating windows is becoming a challenge for us, then it means...
Have you got strategy?
Hello? Was somebody talking? Somebody was talking. Please.
Sorry, it's me. Oh, sorry.
Yes, there's a lot of things we need to know. There's a lot of things we need to explore. What I want to emphasize is that what you can do with Revit is only limited by your own understanding of building systems. So if you don't understand the building system, you can't apply it. But the primary thing is that you must be able to model it in the first place. Then after the modeling, that's where the main job will start. So if you cannot model the pipes, then how can you do pressure testing? If you cannot model the pipes, then how can you generate the sections, the floor plan, the elevation, the details? If you cannot model them, how can you organize your sheets and then put them on the sheets? We need to set up, please. There's a lot more we can learn. Any question? Godwin.
Yeah, mankind.
Any comment? Since you are a services engineer.
Oh, you were going through some of the possibilities of Revit in terms of MEP, and I'm actually surprised at I didn't know you could actually get schedules of pipes, fittings, and whatnot. It's actually impressive, and you can even attach the cost. Meaning you can just produce your bill of quantities out of the drawing.
Yes, you can do that.
That's very, very. It's to save a lot of time. A lot of time. I mean, if we can get to that level, I'll be very happy.
So we just need to push ourselves. For me, at your level, at least every issue, any challenge that you have, I can assist you with them. But I expect all of you to push yourselves. Because if you don't ask questions, I'll pretend that nothing is happening. So I expect you to use it. Face challenges whilst you're using it. Bring the challenges up. And let's get them addressed. Maybe in our 6 months time or between 6 months and a year time, you might have worked on 2 or 3 projects or which might require you to further enhance your knowledge. Then we can discuss the mastery level course. But for now, let's just focus on at least how to model and how to do basic documentation, because there are more things that we can do in terms of analysis. Because if you go to analyze here, for instance, we can do a lot of analysis for spaces and zoning. Okay, we can generate report and schedules, panel schedules and quantities, duct pressure report, pipe pressure report. So if I go to pipe pressure report, you can create anything that you want to do. But for now, we've not created any system. So if there were to be any system created, you can see them and then generate pressure reports that you want to do. There's a whole lot of things that you want to do. If you want to do energy optimization, there are tools that we can do. You can define your location. You can create an energy model from your project. And when you create the energy model, then you can use it to do system analysis and all those things. They are all there. All these things are there. All the things the white people are using to smooth us, they are there. We can learn them. But we are always finding excuses not to learn. Please, the tools are there. If you all can collaborate and share ideas, there are so many things that we can do together. But it's unfortunate, everybody is keeping his knowledge silent. Everybody thinks he knows enough. He doesn't want to share anything that you want to share. But collectively, we don't know anything. And please, if you are using Revit at the discipline level, you might feel very comfortable that I can model, I can render, I can do working drawings. So, but when you get to a level where you are working in a collaborative workspace, you have 6 Revit experts working together. Architect is an expert Revit user. Structural engineer is an expert Revit user. Mechanical engineer is an expert Revit user. Electrical engineer is an expert Revit user. Then you are all working on a project together, using in a collaborative workspace, using these tools here, collaborate here, collaboration here, and coordination here. That is where Revit shines best. But if you are using Revit at just discipline-specific level, I can assure you, you are swimming in children's pool. Or at best, you are swimming in a domestic residential pool. There are some people who are swimming in the seas, in the oceans, when it comes to Revit. So you should just up your game and then see how you can get there. I'm done for the day. If you have a question, you can ask. Or if you have a suggestion, you can make.
Mankind.
Yes, sir.
So let's say I get a project right now I'm working on. What will be the first step I have to take to start the design?
For now, you don't have a template. Ideally, any project that you are starting with on a live project, you must have a personal or office template that you need to work with. And that template will take care of all your piping, your electrical, all the content you are working with, both system and loadable content, your views, your sheets, your presentation. And then we are here to get there. If you have a template, then it means you are ready to start a project. But if you start a project in Revit, then you start with the default template. That's a shape of the software. Then it means that you are going to land on a rock. You can't make any meaningful impact on the project. So you need to be able to get a personal, well-designed template before you attempt it on a real-life project. Until you get a template, you are not ready to start a project. That's point number one. Point number two, you must understand the documentation process very well. How to generate your views, general arrangement views, detailed views. The detailed views, we have assembly details, we have enlarged views, component details, sub-component details, how to do your schedules, how to do your legends, how to do sheet composition, and all those things. And if you get all those things right, all of them will be incorporated into your template. So until you get a good template, you are not ready to work on a live project. You find yourself wanting because you have to move back and forth, back and forth. You have to be moving between one project and another. You will see yourself doing repetitive work in one way or the other. So the objective of this course is to guide all of you so at least you can get a good template. So when you are starting a new project, you know that this template I'm starting with is something worth working on. And one thing is that you can always be updating your template because your template that you are working on today, after you work on it after 1 month, you get new ideas, you get new libraries, new content. Then you have to update the template to let's say version 2 or version 3. So that you always keep on, just like we update our mobile apps now, you can always be updating your template. So the template you work with today and the template you work with in a year's time will not be the same. So by a year's time, you have a very rich template. None of you here can compare your template to my personal template, no. Because I've been working with Revit for how many years? About 14 good years. Or no, 2009 to now, it's about 16 good years. So my template is definitely very richer than your own. So when I start a project, I am miles ahead of you.
Oh, mankind, are we done?
Yes, if you have a question, you can ask.
Oh, no question, no question.
Yes. And 3, you see, Revit is made up of 4 environments. Like I always say, we have the project environment, which we are currently working in. Then we have the new family environment. So you can pick on any family. Maybe I want to create any family. For instance, I want to create, let's say, a duct. So I'll go to metric ducts T. When I open this one here, it's a new template that I can use to create a duct. And if you look at the interface is totally different from what? The project environment. We have create, we have insert, we have annotate, we have view, we have manage, we have add-ins, we have modify. So if you are a designer and you don't know how to work within this family editor, then it means that even your crutches is deformed. You are always a cripple, you are working with the crutches, and the crutches you are working with is already deformed. You understand? So you must know how to work in this environment. Then we also have new annotation family, new annotation. So you can come in here and then create any tag you want. Session head, room tag, level tag, grade head, generic tag, fire alarm device tag, electrical equipment tag. And when you open that one too, the interface is also totally what? Different. Totally different. So if you want to create any annotation stuff, this is where you design them. We have spaces we design, then we have the project environment. If you want to create your own custom title block, you go to new and then go to title block. Then you can also choose the sheet size you want. Maybe A2. Then you come to open. Within this view, you can also design your own title block the way you want it. You can't design your own title block. You can't design your own annotation tags. You don't have a template. You want to do a PPR pipe. You don't know how to design your own PPR pipe. Then how are you going to develop the project? You go through the Revit libraries and there is no PPR pipe. You want to do a 4-bay louver blade with fan light at the top. And you want the fan light to be glass with ginger symbol inside it, and the glass symbols inside it. And you don't know how to do it. So what do? This is where we must all come in and then sit up and then exchange ideas and then move ahead. But I go to a certain point, and people thought they knew Revit. So they were not willing and prepared to share ideas. They started shifting to their own corner. At this setup, Revit user group, as far back as the year 2011, nobody was contributing, nobody was making input to it. Even the current one that I set up, nobody's commenting, nobody's making a contribution. I'm only making vulgar noise into people's ears here and there. You post something, nobody comments. You post something, nobody criticizes. Few people just like it and then move on. And if you continue that way, there is no way we can make a progress. And that's where we are right now. Currently, I don't practice as an architect. Neither do I practice as a building service professional. I'm into programming. I do this because I can do it. I do it as a hobby. This project that I'm doing with you, I am doing it as a hobby because I became unemployed because of what I decided to do. So I do it as a hobby. If you get to a certain point, I still realize that people are still not interested. I can pack my bag and baggage, close the docket on Revit or BIM or whatever, and then move on and then do my programming. Now I'm a full stack web developer. That's what I do for a living now. This one is just a side issue. Because if I don't do it, nobody will do it. That's why I'm doing it. A good point to stop. Some of us should take it up. Some of us who call ourselves architects, who call ourselves engineers, who call ourselves architectural technologists, who call ourselves contractors, builders, we must take this thing up and then develop it. Technology does not evolve on its own. It is people that make technology work. And if we are not willing and prepared to collaborate and share ideas and build upon what we know, but we want to rely on our individual knowledge silos, it's costing us already. You enter most architecture offices, you enter most engineering offices, and you can smell poverty. Not because they can't afford, but because they are not interested. Even the laptops, the desktop, the workstations they are supposed to buy to run the offices, they are not ready to buy them. Meanwhile, if you go to the individual private residences, they are living like Arabian kings. But the offices that they run, they are not willing to spend a dime in those offices. And if you don't invest in the technology, who will come and invest it for you? Most of the offices that are consulted with between 2009 and 2014, they will only call you only when a foreign consultant will tell them that if you are not using Revit, I cannot work with you. Then they expect you to come and do magic. It won't happen. And because of that, all the good works, all the juicy works, they are done outside and brought into the country. Then you see our big men calling themselves local content advisors or whatever, doing supervision and then collecting peanuts. Most of our consulting firms have been converted into project management firms. They can't design, they can't document, they can't do anything. So everything is done from outside, it's brought to us, then we'll be blowing our hands over them. All the good projects, you know them. Just because, not that we are not good architects, not that we are not good engineers, but the fact of the matter is that we have failed to invest in our offices technologically. How many people in your offices do you get internal professional training? Go for workshops, go for seminars to upgrade their skills? No. An architecture firm expects to rely on the knowledge of a fresh architect's work to deliver on a project. Meanwhile, the fresh architect who has graduated from tech, doesn't even know how to do a working drawing. The only thing he knows how to do is sketch design. And how do you expect to use such a person to deliver on a project? You can't. Our technicians have been restricted in their training that technicians should not be allowed to do more than 3-story building while they are going under training. And when a technician graduates from school, you expect him to be able to work on a hospital complex with you. You expect him to do a working drawings on a 14-story building with you. He can't. That is the state of affairs in the country now. And if you don't do anything about it, please, nobody will do anything about it, though. Nobody. This information I'm giving to you is real because I know. I've worked with almost every office in Ghana. I've worked with almost every architect, every engineer in Ghana, and I know where I'm coming from. We are in a deep shit. We are in a deep shit. So if we don't sit up and upgrade our knowledge and decide to make a mark and make a difference with what we know, and we stick on rendering, visualization, rendering. What is rendering? Please, what is rendering? Architects will go to school for 6 good years and turn out and tell me I'm a visualizer. What the hell is a visualizer? Meanwhile, the person cannot produce a working drawings. He cannot do detailing. We do a scheme and we do average of 15 to 20 sheets. How many architects in Ghana can produce 85 sheets on a residential scheme? We don't produce reflected ceiling plans. We don't produce tiling plans. We don't produce finishes. We don't produce anything. Just basic floor plan, sections, elevations, then window schedule. Then they add the last sheet, fence wall detail and septic tank details. What the hell? And you see the same drawing all over, especially the fence wall and the septic tank details. All over. So at the end of the day, the sketch design we produce in the office is different from the working drawings, is different from the as-built drawings. And whom are we deceiving? And a project that we project that it will cost $30 million, by the time we finish with the project, variations alone will shift the project to $120 million, including national projects. We can sink $58 million into a pool without getting a check. Meanwhile, we had an international architect of acclamation working on the project. What are you telling me? A word to the wise is enough.
Hey, mankind, ceasefire. If you
No,
listen,
it's war, madam.
you don't worry. Let's continue tomorrow.
Okay.
Okay. Bye-bye.
Bye-bye.